How could our world end? It's a question most of us push to the back of our minds, a thought too big and too unsettling to carry around in daily life. When you walk outside and see the sky overhead, when you feel the ground beneath your feet, it all feels so solid and unchanging. The earth seems permanent, like it will always be here, no matter what happens. The trees look rooted forever, the mountains seem immovable, and even our cities of steel and concrete give the impression that they will outlast us all. From our point of view, the world feels stable, but the truth is, it isn't. If you look up at the night sky, it feels peaceful. Stars twinkle from unimaginable distances, the moon hangs quietly, and sometimes a shooting star streaks across the dark. To most of us, the heavens feel remote, beautiful, and harmless. But hidden in that same sky is one of the greatest threats to life on Earth. Rocks, ice, and debris left over from the birth of the solar system, traveling silently through space until by chance their path crosses ours. An asteroid or comet, just one among countless fragments drifting in the void, could one day fall to Earth and end the world as we know it. The danger is not hypothetical. It has happened before. 66 million years ago, a rock about 10 kilometers wide, larger than Mount Everest, slammed into the Yucatan Peninsula of Mexico. The impact released more energy than every nuclear weapon on Earth combined. The blast wave vaporized everything nearby. Shock waves circled the globe, and debris shot into the upper atmosphere. Within hours, wildfires raged across continents. Within days, sunlight dimmed under a haze of dust and ash. The climate collapsed, photosynthesis failed. Food chains broke apart. In just a geological instant, the age of the dinosaurs ended. Over 70% of Earth's species vanished, and the planet reset itself for mammals to rise. That single rock, just a speck compared to Earth, changed the course of life forever. When we imagine the end of the Earth, few scenarios are as dramatic as this. Unlike slow climate shifts or gradual geological changes, a large impact is sudden, merciless, and absolute. One day the world is familiar, the next it is unrecognizable, and because space is vast and unpredictable, it could happen again at any time. Most of the time, of course, Earth is lucky. Our planet is constantly struck by objects from space, but most are tiny. Every day, hundreds of tons of dust and pebble-sized meteoroids burn up harmlessly in the atmosphere, giving us the shooting stars we admire at night. Larger rocks, the size of cars or small houses, hit every few years, but usually in oceans or empty land, leaving only brief fireballs. These events remind us that Earth is not a closed world, but part of a cosmic shooting gallery. But the real danger comes from objects larger than 1 kilometer across. Impacts of this size are rare, maybe once every 500,000 years or so. But when they happen, they cause mass destruction on a global scale. And while the odds may seem small in human terms, over millions of years the chances add up to certainty. Earth has been struck many times before, and it will be struck again. The only question is when. Scientists have spent decades scanning the skies to track these threats. The Near-Earth Object Observations Program, run by NASA and other international teams, has catalogued thousands of asteroids whose orbits come close to Earth. So far, no known asteroid poses an immediate risk of collision, but the solar system is vast, and our surveys are incomplete. New objects are still being discovered all the time, even a rock just a few hundred meters wide too small to wipe out all life, but large enough to destroy an entire region or collapse global trade and agriculture. Could cause devastation beyond anything humanity has ever faced. Think of the Tunguska event in 1908. In Siberia, a space rock about 50 to 60 meters across exploded in the atmosphere with the power of a massive nuclear bomb. It flattened over 2,000 square kilometers of forest, knocking down 80 million trees. Had it struck over a city, millions would have died, and that was just a relatively small impact. In 2013, another reminder came from Chelyabinsk, Russia, where a 20-meter asteroid exploded in the sky, shattering windows and injuring over 1,000 people. The universe does not need a mountain-sized rock to remind us of its power. Even small ones are enough to shake our illusion of safety. When we picture a large asteroid impact, it is easy to think only of the crater it leaves, but the true devastation goes far beyond that. The impact itself would release unimaginable heat, igniting wildfires across continents. Shock waves would trigger earthquakes and tsunamis, leveling coastlines and cities. The real killer, though, would be the atmosphere. Dust and soot launched high into the stratosphere would block sunlight for months, or even years, plunging the planet into darkness. Crops would fail, ecosystems would collapse, and famine would spread. The Earth would not just suffer a strike, it would suffer a long winter of its own making, a nuclear winter without the bombs. In the case of the dinosaur-killing impact, the darkness lasted for years, and global temperatures plummeted. When sunlight finally returned, the greenhouse gases released by fires and vaporized rock caused temperatures to swing in the other direction, heating the planet dramatically. This double blow, first freezing then burning, was too much for most species to survive. If such an impact happened today, the result would be the end of civilization as we know it. But asteroids are not the only danger. Comets, icy bodies from the outer solar system, also pose a threat. Unlike asteroids, which often follow predictable orbits, comets can appear suddenly pulled inward from distant regions by gravitational nudges, traveling at much higher speeds than asteroids. Even a smaller comet can release catastrophic energy on impact. The difference is that we may have only months or years of warning before a comet arrives, far too little time to prepare. It is humbling to realize that despite all our technology, our planet is still vulnerable to these ancient wanderers of space. We have mapped the stars, walked on the moon, sent probes to the edges of the solar system, and yet a rock or an ice ball drifting silently for billions of years could undo everything in a single moment. The universe does not negotiate. It does not care about civilizations or species. It only follows the laws of physics, and sometimes those laws deliver a blow we cannot avoid. Still, humans are not entirely helpless. For the first time in Earth's history, one species is aware of the threat and has the tools to act. Scientists have proposed ways to deflect dangerous asteroids, nudging them off course long before they reach us. One method is the kinetic impactor, a spacecraft designed to slam into the asteroid and shift its orbit slightly. Even a small change, applied years in advance, could make the difference between a near miss and a direct hit. In fact, this is no longer just theory. In 2022, NASA's DART mission successfully tested this idea by crashing a spacecraft into the asteroid Dimorphos, changing its orbit. It was the first time humanity deliberately altered the path of a celestial body. The experiment proved that planetary defense is possible, that for once we are not simply waiting for fate, but trying to shape it. Other ideas include using lasers or mirrors to heat part of an asteroid, creating a jet of vapor that slowly pushes it off course, or even deploying a gravity tractor, a spacecraft that hovers near the asteroid and pulls it gently with its own gravitational tug. These sound like science fiction, but they are grounded in real physics. The challenge is timing. We need decades of warning to make such solutions work. Without that, there is nothing we could do. What does all this mean for the question of Earth's end? On one hand, asteroid and comet impacts are certain over long timescales. They have shaped Earth before, and they will again. On the other hand, the chances of a truly world-ending impact in our lifetimes are low, but low is not zero. And when the stakes are civilization itself, even small risks demand attention. The larger truth is that impacts remind us how fragile life is in the face of the cosmos. A planet feels stable, but all it takes is one rock, one random alignment of orbits, to erase millions of years of history. When we look at the moon, pocked with craters, we are seeing Earth's own history mirrored back at us. The only reason our planet looks smoother is because erosion, weather, and tectonics have healed its scars. But those scars are there, hidden in stone, silent reminders that the sky has teeth. There is also a philosophical weight to this. If the dinosaurs could be wiped out in an instant, what makes us think we are different? We pride ourselves on intelligence, on building machines, on shaping the planet itself. But in the face of a 10-kilometer asteroid, all our power is meaningless. Our entire story, the rise of cities, the writing of books, the building of monuments, could be ended in a single day by a piece of rock that never even knew we existed. And yet this awareness may also be our strength. Dinosaurs never saw it coming. We can watch the skies, we can prepare, we can build defenses. Perhaps that is the deeper meaning of this threat. It challenges us to think beyond the illusion of safety, to recognize that survival requires foresight. The cosmos will not protect us. If we wish to endure, we must learn to protect ourselves. So how could Earth end? By fire from above? The scenarios range from the small to the absolute. A Tunguska-sized impact could devastate a region, collapsing economies and societies in chaos. A larger strike, like the one that killed the dinosaurs, could reset the entire biosphere, erasing humanity altogether. And an even larger one, though exceedingly rare, could sterilize the planet, boiling oceans and vaporizing the crust, leaving Earth lifeless. These possibilities may sound remote, but in the timescales of geology and astronomy, they are inevitable. The universe has no concern for our calendars. Whether tomorrow or 10 million years from now, the rocks are still out there, circling, waiting. The Earth is not as secure as it feels beneath our feet. Above us, unseen, the sky holds both beauty and danger. And that brings us to the haunting truth. When we look at the stars, we are not just looking at the backdrop of our lives. We are looking at the source of our most fragile vulnerability. The night sky may seem eternal and peaceful, but it carries within it the seeds of Earth's ending. The question is not whether another rock will one day fall. It will. The question is only when, and whether we will be ready. When people imagine the end of the world, they often look up. They think of asteroids hurtling down from space, or comets blazing across the sky, or some cosmic event beyond our control. But the truth is, danger does not only come from above. The Earth itself carries the seeds of its own destruction deep inside. Beneath our feet lies a restless engine, a hidden world of molten rock and immense pressure, always moving, always shaping the surface we walk on. To us, the ground feels solid, but if you peel back the thin crust that makes up the continents and oceans, you find that the Earth is not solid at all. It is alive with heat and motion, and sometimes it reminds us of that fact with terrifying force. Volcanoes, earthquakes, tsunamis. These are Earth's own weapons, born from its restless interior. Most of the time, they are local disasters, terrifying but contained. A single earthquake can flatten a city. A single eruption can bury towns in ash. But every so often the Earth unleashes something far greater, something that shakes the entire planet. These rare events remind us that our world is not a stable stage, but a fragile crust balanced on fire. Let's start with the most dramatic supervolcanoes. A regular volcano, like Mount Vesuvius or Mount St. Helens, can cause massive destruction, but a supervolcano is in a different category altogether. A supervolcano is not just a mountain spewing lava. It is a hole in the Earth's crust so vast that when it erupts, it releases thousands of times more material than any ordinary volcano. These are eruptions that can darken skies across the globe, cool the climate for years, and threaten the survival of entire species. One of the most famous supervolcanoes sits quietly under Yellowstone National Park in the United States. To tourists, Yellowstone is a wonderland of geysers, hot springs, and colorful pools. But all of these are surface signs of something far larger, a giant magma chamber lurking beneath the ground. This chamber is so vast that if it erupted at full force, it could cover much of North America in ash and throw enough particles into the atmosphere to block sunlight across the planet. Crops would fail, temperatures would drop, and famine would spread worldwide. Scientists studying Yellowstone know that it has erupted several times in the past, the last one about 640,000 years ago. Each time, it left behind craters tens of miles across, marks of explosions so great they make modern eruptions look like sparks. Yellowstone is not the only supervolcano. There is Lake Toba in Indonesia, which erupted about 74,000 years ago, releasing so much ash that it may have nearly wiped out early human populations. Some genetic studies suggest that humanity was reduced to just a few thousand individuals at that time, barely clinging to survival. In New Zealand, the Tofo volcano has had enormous eruptions in the past. In Italy, the Campiflagre caldera bubbles beneath Naples, one of the most densely populated cities in Europe. All around the world, these sleeping giants remind us that Earth does not need a visitor from space to bring catastrophe. It can do it all on its own. The danger of a supervolcano is not just the lava or the ash that buries nearby land. The real threat is the atmosphere. When enough ash and sulfur gases are blasted into the stratosphere, they can spread around the entire globe, blocking sunlight and cooling the Earth for years. This is called a volcanic winter. Crops would fail, ecosystems would collapse, and billions could starve. Unlike an asteroid strike, which might give us no warning, supervolcanoes often show signs of unrest, earthquakes rising ground, changes in geysers. But even with warning, there is little we could do to stop such an eruption. At best, we could prepare for survival. Earth's fury does not only come in eruptions, it also comes in the form of earthquakes. The ground beneath us is broken into giant plates that float on the semi-molten rock below. These plates grind, collide, and slide past one another in slow motion, building up pressure along fault lines. When that pressure finally releases, the result is an earthquake. Most are small, barely felt. Some are devastating, collapsing cities and killing thousands. And in the right conditions, earthquakes can trigger tsunamis, giant waves that race across oceans, wiping out coastal communities. One of the most infamous earthquakes struck in 1556 in China's Shanxi province, killing an estimated 30,000 people. In 2004, an earthquake off the coast of Sumatra triggered a tsunami that killed over 30,000 across 14 countries. In 2011, Japan suffered a massive quake and tsunami that not only destroyed towns but also triggered the Fukushima nuclear disaster, spreading radiation into the environment. These are reminders that the Earth itself can shake us to our core, literally. And then there are events even more dramatic, the breakup of continents. Over millions of years, the continents drift across the globe, carried by the slow movement of tectonic plates. They collide to form supercontinents, and then break apart again. This process has reshaped Earth again and again. When continents collide, they push up mountain ranges like the Himalayas. When they split apart, they open vast rift valleys and new oceans. The movement is slow, but the consequences are enormous. Imagine a world where continents are arranged differently, where oceans shift and climates transform. For humans dependent on stable coastlines and climates, such changes would be devastating. Beneath all of this lies the engine that drives it, the molten interior of Earth. Our planet is still hot from its birth, heated further by radioactive decay in its core. This heat keeps the mantle moving, keeps plates shifting, keeps volcanoes alive. As long as Earth remains geologically active, it will never be truly stable. And if we think about the end of the world, we must accept that fire from within is always part of the risk. Some scientists have even speculated about more extreme possibilities. For example, a runaway volcanic event called flood basalt eruptions, where huge fissures open in the ground and pour out lava for thousands of years, releasing enough gases to poison the air and change the climate dramatically. Events like this have happened before, around 250 million years ago, at the end of the Permian period. Massive volcanic activity in Siberia released so much gas that it warmed the climate, acidified the oceans, and caused the largest mass extinction in Earth's history. Over 90% of species disappeared. It is sometimes called the Great Dying. Earth nearly became lifeless, not because of a rock from space, but because of its own inner fire. It is unsettling to think that the ground we walk on, the land we treat as the most reliable thing in our lives, is in fact the source of such danger. We trust the Earth as our foundation, yet the Earth itself is restless and violent beneath the surface. If you could look inside, You would see currents of molten rock flowing like slow rivers, hotter than any furnace, moving mountains 1 inch at a time. You would see immense pressures building along faults, waiting for the moment to snap. You would see pockets of magma, some the size of whole countries, simmering and growing. The Earth is a sleeping giant, and when it stirs, everything on the surface feels it. But just like with asteroids, the question is not only whether Earth can end us, but how likely it is in the timescale we live in. Supervolcanoes do not erupt every day. Massive flood basalts are rare, separated by tens of millions of years. Most earthquakes and eruptions, though deadly, are local rather than global. But the fact that these events can happen, and have happened before, means we cannot dismiss them. In deep time, they are inevitable. For humans, the danger is magnified because our civilization is global and fragile. A supervolcano eruption that cools the climate by just a few degrees could collapse agriculture worldwide, leading to starvation and social chaos. An earthquake in the wrong place could cripple a nation's economy. A massive volcanic eruption could ground planes, cut off trade, and spread disease. Unlike ancient life, we depend on fragile systems of food, energy, and communication. When Earth shakes, our world shakes harder. So how could Earth end by fire from within? There are many paths. A supervolcano could trigger a volcanic winter that humanity cannot survive. A massive series of eruptions could poison the atmosphere and oceans, driving life to extinction as in the Permian. A giant earthquake and tsunami could devastate global civilization, collapsing our fragile networks of trade and stability. Or in a slower sense, the constant movement of continents could rearrange climates and ecosystems so drastically that life as we know it cannot adapt. In the end, Earth does not need an asteroid to remind us of mortality. It carries destruction in its own heart. In the restless heat and pressure below, we may build cities, plant crops, and imagine that the land is permanent. But the land itself is only borrowed from a planet that is always changing, always remaking itself. And yet, as frightening as this is, it also connects us to the deep story of our planet. Life has survived countless disasters, clawing back after each ending. The Earth has burned, frozen, split apart, and drowned, and still life has returned. The question for us is not whether Earth will endure, but whether we will endure with it. We are clever, but we are not invincible. To survive the Earth's fury, we must remember that stability is an illusion, and that the fire beneath us is as much a part of our world as the air we breathe. Perhaps the greatest lesson of all is humility. The ground beneath our feet is not as safe as it seems. The Earth is a living planet, and living things do not stand still. If the end comes from within, it will not be because the Earth betrayed us. It will be because we forgot that we were always living on the surface of a giant, restless, burning sphere, and that the fire we walk above has always had the power to change everything. When people imagine the end of the world, they often picture forces beyond human control. Asteroids crashing from the sky, volcanoes shaking the land, the sun swelling in the distant future. These are natural disasters, written into the fabric of Earth and the cosmos. But there is another possibility, one far closer, one that grows from our own hands. What if the end of the world does not come from above or below, but from within us? Unlike the dinosaurs or the trilobites, we are not powerless creatures simply reacting to the environment around us. Humans are different. In just a few centuries, we have reshaped the planet more than any species before us. We have split atoms, tamed rivers, burned forests, drilled oceans, and rewritten landscapes. We have built machines that move mountains, factories that alter the air, and networks that circle the globe. We are no longer simply part of the ecosystem. We are engineers of it, but with this power comes danger. For the first time in Earth's history, one species has gained the ability to destroy not just itself, but much of the planet along with it. When we ask how Earth might end, we cannot ignore the possibility that it may end by our own doing. Not with one sudden blow, like an asteroid, but with many small choices that accumulate into something unstoppable. The first and most visible threat is climate change. For hundreds of millions of years, Earth's climate has shifted naturally, warming and cooling as continents drift, as volcanic gases rise, as ice caps wax and wane. But in the last 2 centuries, humanity has added something new. Billions of tons of carbon dioxide and methane released from burning fossil fuels, coal, oil and gas, ancient sunlight stored in stone, have been dug up and set alight in quantities nature never prepared for. The result is a chemical fingerprint written into the atmosphere, one that scientists can measure with precision. The levels of carbon dioxide in the air today are higher than they have been in millions of years, and they are rising faster than at any point in Earth's history. The effects are already visible. Average global temperatures have climbed by more than 1 degree Celsius in just over a century. Ice sheets are melting, seas are rising, heat waves are intensifying, storms are growing stronger. What was once theoretical is now part of our daily weather. Entire regions are facing droughts that last for years, while others are drowning in floods. Coral reefs, once thriving ecosystems, are bleaching and dying as oceans warm and acidify. Insects and birds are shifting their ranges, trees are dying back, wildfires are spreading across continents. The Earth we inherited is not the same Earth we are passing on. But the danger of climate change is not just in these visible events, it is in the tipping points, the feedback loops that make warming spiral faster than expected. As Arctic ice melts, it exposes darker ocean water that absorbs more heat, which melts more ice. As permafrost thaws, it releases methane, a powerful greenhouse gas which warms the Earth further. As forests burn, they release the carbon they once stored, adding to the problem. Each of these loops pushes the climate further away from stability, toward a new state that humans may not be able to survive. If this continues unchecked, the world could face conditions far harsher than anything in human history. Crops may fail in regions that once fed millions. Rising seas could flood coastal cities where billions live. Heat waves could reach levels lethal to humans, making some regions uninhabitable. Wars and conflicts could spread over shrinking resources, water, food, land. Civilization depends on stability, but climate change threatens to take that away. And unlike asteroids or volcanoes, this disaster is one we are actively building. Yet climate change is not the only danger humanity has unleashed. Another shadow hangs over us: nuclear weapons. In 1945, when the first atomic bomb was detonated, a new chapter began. For the first time, humans had the power to destroy cities in an instant. In the decades since, that power has grown beyond imagination. Today, there are thousands of nuclear warheads stored in silos, submarines, and aircraft around the world. Each one is many times stronger than the bombs that destroyed Hiroshima and Nagasaki. Together, they hold the power to erase civilization. The greatest danger of nuclear weapons is not just the blast itself, but the aftermath. If hundreds or thousands of warheads were ever launched, the fires they ignite would throw massive amounts of smoke and ash into the stratosphere. Sunlight would be blocked, plunging the world into what scientists call a nuclear winter. Crops would die, temperatures would fall, and billions could starve. Radiation would spread across continents, poisoning land and water. The Earth itself would survive, but human civilization might not. It is a reminder that our greatest threat may not come from the sky, but from our own decisions, our own politics, our own fears. There is also the quieter danger of collapse through overconsumption. In the last 2 centuries, humanity has used resources at a pace Earth cannot replenish. Forests are cut faster than they regrow. Fish are taken faster than they reproduce. Groundwater is drained faster than it refills. Species are driven to extinction at rates far above natural levels. We are reshaping ecosystems on every continent, leaving behind fewer and fewer untouched places. Scientists now speak of a 6th mass extinction, this one caused not by asteroids or volcanoes, but by us. This extinction is slower than a comet strike, but its results could be just as severe. Ecosystems are networks, each species connected to others. Remove enough threads, and the whole web collapses. Pollinators vanish, crops fail, predators vanish, prey populations explode and then collapse. Coral reefs die, and with them the fish that feed millions. As biodiversity shrinks, the resilience of the planet shrinks with it. The Earth becomes less able to withstand shocks, more likely to tip into states we cannot control. Even our technology, our proudest achievement, carries risks that could end the world. Artificial intelligence, synthetic biology, nanotechnology, tools we are only beginning to master, could be used in ways that spiral beyond our control. A virus engineered in a lab could spread across the globe. A rogue AI could disrupt societies or even control weapons. These are not certain paths to doom, but they are doors we have opened without fully understanding what lies behind them. And then there is plastic, the most ordinary symbol of our modern life. It wraps our food, fills our oceans, litters our soil. It is so durable that it does not truly vanish, only breaking into smaller and smaller pieces. Already scientists find microplastics in rivers, in the air, in the stomachs of animals, even in human blood. Plastics may one day form a permanent layer in the geological record, a plastic horizon that future beings, if any exist, will recognize as the mark of our age. It is a reminder that even small conveniences multiplied by billions can leave scars as lasting as volcanoes or asteroids. When we put all these together, climate change, nuclear weapons, overconsumption, extinction, pollution, and the risks of technology, we see a picture of a species capable of writing its own ending. Unlike natural disasters, these threats do not come from outside. They come from us. The Earth does not need to strike us down. We may be doing it ourselves. But perhaps the most sobering part of this story is how quickly it has all happened. For most of human history, we lived within nature's limits. Small populations scattered across the land, surviving on hunting and farming. Only in the last few centuries have we gained the power to change the entire planet. In just a handful of generations, we have altered the air, the seas, the land, and the climate. The speed of this transformation is unmatched in Earth's history. Even mass extinctions of the past unfolded over thousands of years. Ours is happening in mere centuries. So how might Earth end because of us? There are several paths. We could burn fossil fuels until the climate crosses tipping points that make it unlivable. We could unleash nuclear war, plunging ourselves into darkness. We could consume ecosystems until they collapse, dragging us down with them. Or perhaps a chain of smaller mistakes, pollution, habitat loss, disease, war, could combine into one global unraveling. The end might not be one dramatic event, but a slow decline, a civilization crumbling under the weight of its own success. Yet even as this is frightening, it also carries a strange truth. If humanity has the power to end the Earth as we know it, then we also have the power to save it. Climate change can be slowed if emissions fall. Nuclear war can be prevented if weapons are controlled. Ecosystems can recover if given space and time. Species can be protected. Forests can regrow. We are not powerless victims of fate. We are participants with choices that matter. The danger of the heat of our own making is not just that we might destroy ourselves, but that we might forget our responsibility. The Earth will survive regardless. It has endured worse, but the Earth that survives may not be the Earth we know. The Earth that nurtures us, it may be a hotter, emptier, harsher world, with humanity gone or reduced to fragments. The rocks will still hold our story, but it will be a story of a species that burned bright and fast and then was gone. In the end, the question is simple and yet immense. Will our greatest legacy be our own destruction? The traces we are leaving, plastics, carbon spikes, nuclear isotopes, look eerily similar to the fingerprints we imagine when we ask if past civilizations might have existed before us. We are already writing our own geological signature. The Earth of the far future will remember us not for our art or our cities, but for the scars we left in stone and soil. Perhaps that is the greatest warning. We are already becoming the kind of mystery that future beings, if they exist, might puzzle over. The Earth has many ways to end, but the most immediate may be the one we are creating ourselves. Fire from above, fire from within. Those are dangers we cannot prevent. But fire from our own hands, that is the one we can. The only question is whether we will choose to. When we think about the end of the Earth, most of the dangers feel immediate. Asteroids, volcanoes, climate change, nuclear war, they are things that could happen in our lifetimes, or in the lifetimes of the generations just ahead of us. But beyond these near-term threats lies something far larger, slower, and inevitable. Even if humanity avoids every mistake, even if we outlast every catastrophe from space or from within, there is one force we cannot escape: the sun itself. The sun is the giver of life. Every leaf that grows, every crop that feeds us, every breath of air we take comes from the energy of sunlight. Plants use it to turn carbon dioxide into oxygen. Animals feed on the plants, and we feed on both. The sun's warmth keeps Earth's surface liquid instead of frozen solid. Without it, our planet would be a cold rock drifting in space. In every sense, the sun is the reason we are here. But like all things, the sun has a lifespan, and one day it will bring Earth's story to an end. To understand how, we need to remember what the sun really is. It is not a gentle fire, but a colossal nuclear furnace. Deep in its core, hydrogen atoms are fused into helium, releasing immense amounts of energy. This energy pushes outward, balancing the inward pull of gravity. The sun has been stable for about 4.5 billion years, giving Earth the steady warmth needed for life. But the sun cannot stay the same forever. As it burns hydrogen, its core changes, and over time, it grows hotter and brighter. This is the hidden danger. The sun that feels eternal is slowly changing, and those changes will eventually make Earth uninhabitable. The process is gradual, almost invisible on a human timescale, but relentless. Scientists estimate that in about 1 billion years, the sun's brightness will have increased enough to trigger a chain reaction on Earth. The added heat will cause oceans to evaporate more rapidly. Water vapor, itself a greenhouse gas, will build up in the atmosphere, trapping even more heat. This runaway effect will boil the oceans away, leaving Earth dry and barren. Long before the sun physically engulfs the planet, Earth will already be unlivable, transformed from a blue world into a desert. Imagine what that will look like. The seas shrinking into steaming basins, coral reefs and fish disappearing, coastlines turning into salt plains, rainforests withering, animals collapsing in the heat, deserts spreading across continents, the sky itself thick with water vapor, trapping the sun's heat until surface temperatures soar high enough to melt lead. Even the rocks would begin to crack under the heat. The Earth that once nurtured forests, rivers and cities would become a wasteland, silent except for the winds of a dying atmosphere. But the story does not end there. As the sun ages further, it will run out of hydrogen in its core. Gravity will crush the core tighter, heating it enough to ignite helium fusion. This change will make the sun swell enormously, turning into what astronomers call a red giant. Its outer layers will expand outward, growing so large that the sun will swallow Mercury and Venus, and possibly Earth as well. Even if Earth escapes being fully engulfed, it will be scorched beyond recognition. The crust will melt, the atmosphere will be stripped away, and the planet will become a charred rock orbiting a bloated star. This transformation into a red giant will not be a sudden explosion, but a slow, drawn-out process over hundreds of millions of years. Still, from Earth's perspective, it will be apocalyptic. The sun's outer layers will blast powerful solar winds, stripping planets of their atmospheres. The sky, if anyone was still there to see it, would glow with a swollen, blood-red star filling half the heavens. Oceans would have long since boiled, mountains would be rivers of molten rock, and the air would be a furnace. The Earth would not just end as a home for life, it would end as a recognizable planet at all. Eventually, after swelling and shedding its layers, the sun will shrink into a white dwarf, a small, dense core left behind after the red giant phase. This remnant will no longer have the power to fuel nuclear fusion. It will simply cool slowly over billions of years, fading into darkness. The planets that survive will orbit a cold, dead ember. By then, Earth will be gone or lifeless. Its story ended by the very star that gave it life. In a way, this ending is both terrifying and poetic. The sun that warms us today is also our executioner, simply waiting for the passage of time. No matter what we do, no matter how careful or wise we become, the sun guarantees that Earth's habitability has an expiration date. Life here cannot last forever. But while this may sound distant and abstract, there is something meaningful in imagining it. We tend to think of our lives, our civilizations, and even our planet as permanent. But in the cosmic story, permanence does not exist. The sun itself has a life cycle, and we are just passengers in its middle years. Right now, we are lucky. We live in the golden age, when the sun is steady and gentle, when Earth is warm enough for life but not yet too hot. This balance will not last. The question then becomes, what does this mean for us? One answer is humility. It reminds us that Earth is not the final stage for life, but a temporary home. If life wants to continue beyond the sun's changes, it must leave Earth behind. This is why some scientists and dreamers speak of colonizing other planets or even traveling to other stars. In the short term, such ideas seem impossible, but in the long term they are the only way for life to survive. If we remain tied to Earth forever, the sun will end our story. If we learn to reach beyond it, perhaps life can outlast its parent star. Another answer is perspective. The slow death of the sun may be billions of years away, but it shows us how fragile our moment is. We live in a window of time where the conditions are perfect, neither too hot nor too cold, neither too dark nor too bright. Life on Earth exists because of this narrow balance. Knowing that balance will not last forever makes it all the more precious. It also shows us how deeply connected we are to the cosmos. The same nuclear reactions that will one day end Earth are the ones that created the elements of our bodies. The carbon in our cells, the oxygen in our lungs, the iron in our blood, all were forged in stars. The sun is both our cradle and our grave, the cycle that gave us life and the cycle that will one day erase us. Some might find this thought depressing, but others may see it as freeing. The fact that nothing lasts forever does not diminish life. It makes it more valuable. We are living in a brief, extraordinary window when Earth is alive. When oceans exist, when forests grow, when humans can look at the stars and wonder about their fate. Billions of years from now, none of this will remain. But it is here now, and that makes it sacred. So how will Earth end? Because of the sun. First, through a slow heating that boils away its oceans. Then through the swelling of the red giant that scorches or engulfs the planet. Finally, through the fading of the sun into a white dwarf, leaving Earth lifeless, shattered or gone. The timeline is vast, but the outcome is certain. This may sound like science fiction, but it is not speculation. It is written into the physics of stars, confirmed by what we see when we look into the universe. Astronomers can point to red giants in other star systems and know that our sun will one day become the same. They can see white dwarfs, the remnants of stars that once shone like ours, now cooling into silence. The sun's future is not a mystery. It is a promise. The real question is not whether Earth will end under the fading sun, but what life will do before then. Will we burn ourselves out in wars and climate disasters long before the sun has its turn? Or will we endure, learn, grow, and eventually step beyond Earth, carrying the spark of life into the wider galaxy? The sun will not wait for us. It will follow its course. Whether we last long enough to face that distant ending depends on what we do now. Perhaps one day, far from now, descendants of humanity or beings entirely different, born from us or beyond us, will look back at Earth from another star system. They will know that the planet where life first blossomed is gone, erased by the star that raised it, but they will also know that life escaped. That Earth was not the end of the story but the beginning. Until then, we live in the fragile middle, the brief golden age. We walk under the light of a star that is both our protector and our destroyer. We breathe air shaped by plants that feed on sunlight. We eat food grown in fields warmed by it. We live in cities powered by it. Every second, the sun gives us life. And every second it moves closer to the moment when it will take it away. The fading of the sun is the final reminder that nothing lasts forever. Not species, not civilizations, not even worlds. Earth is temporary, and so are we. But within that impermanence lies a choice to live as though nothing matters, because it will end, or to live as though everything matters because it is brief. That is the lesson the sun offers us. It is both our beginning and our ending, both our cradle and our grave. The earth will not survive it, but perhaps if we are wise, life itself will.